We've all had that moment where we pause and think, wait a second, is this a bad idea? Well, in science, there's actually a formal way of asking that question, and learning it can make you safer, not just in a lab, but, well, everywhere. It all comes down to understanding the huge difference between a hazard and a risk.
We throw these words around all the time, right? Dangerous, risky. They feel like they mean the same thing, but spoiler alert, they don't. And getting this difference isn't just a nerdy science thing, it's actually the key to navigating the world a whole lot smarter and safer.
Okay, this slide right here, this is basically the whole idea in a nutshell. A hazard is the thing that has the potential to cause trouble. Think of it as the source of the danger, like a bottle of a toxic chemical. But the risk, that's the chance, the probability that the trouble will actually happen. It's all about how you handle it.
So let's get a solid definition down. A hazard is anything that has the potential to cause harm, period. Let's take a classic lab example. Concentrated acid. Its very nature, its inherent property is that it's corrosive. That ability to burn you, that is the hazard.
Risk, on the other hand, is all about likelihood. It's the what-if question. What's the chance that acid will actually burn someone? You see, if you're using one tiny drop with gloves and goggles on, the risk is incredibly low. But if you're splashing it around without a care in the world, the risk is huge. Same hazard, but two totally different levels of risk.
So how are we supposed to know what's hazardous in the first place? I mean, in a world with thousands of different languages, scientists needed a way to shout danger instantly. And the solution they came up with was brilliant, a universal visual language.
You've definitely seen these symbols on the side of chemical containers. Their entire job is to give you a heads up, an instant warning. And the best part? They're designed to cut right through language barriers. It doesn't matter if you can't read a single word on the label, you'll get the message.
Let's look at a few of the big ones here. You see that flame symbol? You instantly know, keep this away from heat. The skull and crossbones? Yeah, that's the universal sign for seriously toxic. This isn't just something that will irritate your skin, it could be lethal. Even that simple exclamation mark tells you, hey, handle this with care. Each symbol is a critical piece of information, delivered in a split second.
All right, enough theory. Let's put this all into practice with a classic lab safety puzzle I like to call the ethanol challenge.
Okay, so imagine you're the scientist in this next scenario. Your ability to tell the difference between a hazard and a risk isn't just a vocabulary test anymore. It's about to become a very, very practical problem-solving skill.
So here's the setup. A student has a test tube full of ethanol. Now, as that little flame symbol we just saw would warn us, ethanol is flammable. And the student's big plan is to heat it directly over the open flame of a Bunsen burner. I don't know about you, but I can already feel the tension building here.
Okay, time to apply what we've learned. What's the hazard in this situation? It's the ethanol itself, right? Its inherent property is that it's flammable. And what's the risk? Well, by deciding to stick an open flame right under it, that student has just cranked the risk of a fire all the way up to, extremely high. Now, this is the part where a scientist doesn't just panic. They think. They shift from identifying the problem to actually finding a solution. This, my friends, is the art of taking precautions.
In this whole process of actively knocking down the level of risk, that's what we call a risk assessment. Look, you can't change the fact that ethanol is flammable. That's the hazard, and it's not going anywhere. But what you can absolutely change is the likelihood of it bursting into flames. That's the real goal here. Manage the risk.
So here's how that thinking process works. Step 1. Identify the hazard. Got it. Flammable ethanol. Check. Step 2. Evaluate the risk of the plan. Okay. Open flame plus flammable liquid, that equals a very, very high risk of fire, which leads us to the most important part. Step 3. Choose a precaution. And in this case, the plan is so obviously risky that we need to scrap it and change the entire method.
And here is the simple, elegant solution: a hot water bath. By putting the test tube of ethanol in hot water, you can heat it up gently, indirectly, with no open flame anywhere near it. Now notice what just happened. The hazard, the flammable ethanol, it never changed. It's still flammable. But by taking one simple precaution, the risk of a fire just plummeted to almost nothing. That's smart science.
And changing the method is just one tool in what you can think of as a whole precaution toolkit. A good scientist is always thinking about all the options. Could we use a different chemical that's less hazardous? Is our eye protection good enough? Should we be using gloves?
Is there a better piece of equipment for this job? The specific action might change, but the goal is always the same. Bring that risk down.
Now you might be sitting there thinking, okay, this is all great for chemists, but what does this have to do with me? Well, it turns out this way of thinking is probably one of the most useful practical skills you can ever take away from science.
Seriously, this isn't just some dusty lab rule. You do this dozens of times a day without even thinking about it. A busy street is a hazard, right? A car could hit you. So what's the risk? Well, if you try to jaywalk with your eyes closed, it's enormous. But by taking a precaution, like using the crosswalk and looking both ways, you lower that risk to practically zero. See? You're already thinking like a scientist.
So try this out for the rest of the day. As you go about your life, from cooking dinner to maybe even just walking down the stairs, consciously ask yourself, what's the hazard here? What's the real risk? And what's my precaution? You'll start seeing it everywhere. It's a scientific mindset you've been using all along. The only question is, where will you notice it next?